first two problems are a binomial. So again, like I was talking about yesterday, vocabulary, 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 because you don't want to not know what it's asking for or not know what it's talking about. Binomial because there's two terms. As soon as you see a binomial, first thing you want to look for is a GCF. Obviously, when the first number is 1, there's not going to be a numerical GCF. In this case, there's not a variable in the back, so there's no GCF. So GCF, GCF, GCF is the first thing we want to think every time we see a quadratic, no matter what. From there, if it's a binomial, we want to look for subtraction, because if it's subtraction, then that means we can do differences of squares, or at least try to do differences of squares. We did a couple of these. We did 1 or 2 yesterday in the EOC class. So once we see that it's a binomial, it is minus, we're going to try to take the square root of k squared and the square root of 4. And we're going to come out with our factors. K squared, what is the square root of k squared? Good. K. And then we're going to put a k in both fronts. Remember that k squared, so squaring something and square rooting are inverses, so they undo each other. So remember, every time we had like x squared equals 9. How do you undo squaring something? You take the square root. So square root is inverse operations. So ultimately, if you square root something with a square on it, it's just whatever is being squared, whatever the base is. So in this case, it's a k. And then what is the square root of 4? What can I multiply times itself to give a 4? Yep. So we put a 2 and a 2. And every time we square root any number, the square root of any number is always a plus and a minus. Because negative 2 times negative 2 gives me 4. And positive 2 times positive 2 gives me a positive 4 as well. These are our factors. So if all it asks us to do was factor, you're done. There's your factors. If it asks you to solve, can somebody remind me how to solve quadratics? What do I do for my factor point if I'm supposed to solve? Set equal to 0, right? So k plus 2 equals 0. K minus 2 equals 0. If we're solving for k, we're going to move that positive 2 over. So k is going to equal what? That positive 2 becomes a good negative 2. Excellent. And we're going to do it for the other one. That positive 2 is going to become a... So that negative 2 is going to become a positive 2. Beautiful. So then our solutions, our x-intercepts, our roots, and our zeros are going to be negative 2 and positive 2. So literally, if I was to go to Desmos and graph x squared minus 4, you're going to see that graph touch the x-axis at negative 2 and positive 2. And so these are our solutions, also known as x-intercepts, also known as zeros, also known as roots, and I'm sure there's more, but that's all I got at 8:45 in the morning without any coffee. Okay, so number 2. I'm throwing this in there because I think you're ready for it. So first of all, we see that it's a binomial. Binomial because there's 2 of them. We're going to always check for a GCF first. Greatest common factor. 25 and 9, do they have a number in common that goes into both of them? That I could divide them both by? 25 and 9. Other than 1. Because 1 doesn't help us at all. Y'all making me nervous. Multiples of 25. 1 and 25. 5 and 5. And we're done. Multiples of 9. 1 and 9. 3 and 3. So there's nothing in those 2 lists that match other than 1, so we can't take out a numerical GCF. So GCF we've checked. Is it subtraction? It is, so we're going to get in there and we're going to take the square root of both. Now, this one's a little different because we have a number with our r squared. What is the square root of 25? What number times itself will give me 25? 5. Good. 5. 5. What's the square root of r squared? Remember r squared, and we're going to square root it. R. Good. So 5r, 5r. That's our first term. What's the square root of 9? Good. 3, 3. Every time we take a square root, we have a plus and a minus. So again, these are our factors. And if we wanted to solve it, we're going to set those equal to 0. So that's 5r plus 3 equals 0. And then 5r, I feel like I'm running out of space, minus 3 equals 0. These are a little different than the last ones because I have a 5r. What's the first thing I would do to start solving 5r plus 3 equals 0 to get r by itself? Subtract 3. Good. So we'll subtract 3, subtract 3. 5r equals a negative 3. Now, a lot of students get too comfortable with solving these kind when a is 1, especially in Math 1, because you see more of those. We do more of those. We're not done yet. R is not by itself. So what would I do next to get r by itself when the 5r equals negative? Divide by 5. Good. Divide by 5, divide by 5. So r equals a negative 3 over 5. Same thing here, but we're going to add that 3. So now we have 5r. Whoops, that's the wrong color. 5r equals 3. 5 times r, and the inverse of multiplication is division, so we're going to divide by 5. And so r equals a positive 3 over 5. And you may see those as decimals, as answer choices, but if that's the case, hopefully you understand that you can convert those to decimals in your calculator. All right. Now, I don't know about you. People always panic when they see these. So it is a binomial. Meaning there's two terms. It is subtraction, but what we want to check for first always is GCF. See if we can get it smaller. So like I mentioned in hockey stick method, what I like to do, I know we're going to try to find a GCF. 56, does 56 go into 72? Because I always check my first number first. So 72 divided by 56 is a decimal, so that's no good. Right, good job, Elijah. So we want to think about what numbers go into both of those numbers. What is the largest number? Or at this rate, you can pick any number. Can you think of a number? What number would you try to go into both? So just a smaller pen. All right, let's start with 2. Perfect. So if we pull out a 2, 56 divided by 2 is going to give me 28. They're both negative. Let's go ahead and pull out a negative 2 because we'd like the first number to be positive. So then that's going to give me a 28 positive k to the 5th power. 72 divided by negative 2 is going to give me what? What's 72 divided by 2? Good. And we pulled out the negative, so this is going to become a positive 36. K to the 4th. These are still fairly big numbers. So with that 28 and 36, what other number do you think they might be divisible by? 4. Okay. So we'll pull out a positive 4. 4 times what gives me 28? 7. Good. 7. K to the 5th. I like it when I see a number that I know is only divisible by itself in 1. That means we're getting close. What is 36 divided by 4? Good. 9. K to the 4th. 7 and 9 are now in their most simplest form because it's 7 and 1, 9 and 1, 3 and 3. So there's not a number bigger than 1. So we're going to move on down the line to our K's. So to our variable. So we know we're going to pull out a K because there's a K in both. What's the lowest exponent in these two terms? Between the two terms. The lowest exponent, 4. So we're going to go and pull out 4 K's at one time. Whatever the lowest exponent is, you know there's at least that many. So our 7 is going to stay. If I had 5 K's but I pulled out 4, how many K's do I have left? If I had 5 and I pulled out 4, I'm left with 1. So we don't need to put 1 up there because 1's assumed. Go ahead and give me my 9. There's 4 here, 4 on the outside, so there's none left. 7 and 9 are good. There's a K without a K, so now we have our simplified form. You're going to multiply down the side. So negative 2 times a positive 4. What does negative 2 times a positive 4 give me? Negative 8. And then times K to the 4th. Open parentheses, put your last hockey stick. you have now solved by factoring GCF. So this is your factors. For sake of time, we're not going to do it. But if we wanted to solve, you would take the first one, set it equal to 0, and the second one and set it equal to 0. This time you would set the first one to 0 because there is a variable there. So negative 8k to the fourth equals 0. You would divide by negative 8, and then you would take the fourth root of 0, which is going to be 0. Okay? Looking at our next guy. 63 and 14. What's the biggest number you can think of that they both have in common? And you don't have to be the biggest number right off the gate. Just what's the number you think they both have in common you want to try? Sure, let's try 7. So 63, is it divisible by 7? If I divide 63 by 7, what do I get? 9. Good. So 9m squared. 14 divided by 7 is 2. Perfect. 9 and 2 have nothing in common numerically because 2 is going to be 1 and 2. 9 is 1, 9, 3 and 3. So we're done there. Moving down the line, we have a variable in our first term, but no variable in our second term. So we're done. That's it. That's our factors by GCF. Now, if it was to solve, 7 is never going to equal 0. So you don't even have to do the first one because there is not a variable there. If that was 7m, then you would type 7m equals 0 and solve for m. There's no m there, so you'd only have to solve this second one. It's going to be real ugly, so we're not doing that. But same aspect of solving, so finding where it touches the x-axis. Now, where you're going to see more of these, because this is huge and ugly. So trinomial. Trinomial factoring is our big thing in Math 1. So 54 and 42, what number do you think they both have in common that you'd like to try? Want to try 2? All right, we'll try 2. So what's 54 divided by 2? Oh, no. 54 divided by 2 is going to give us something bigger than that. Yep, 27. Perfect. We'll leave our b squared plus, what's 42 divided by 2? 21. And then we got 54 again, so that's going to be another 27. 21 and 27, they're still fairly big numbers. So I bet there's going to be another number we can pull out. What's another number they both, all 21 and 27 have in common that I could pull out? Doing it hockey stick method, you can pull out the first number you want. 27, is it divisible by 6? 3. So Elijah, 6 would have probably is going to be what they in the beginning. If we pulled out a 6, we'd be fine. But here where we are, 3 is the one we're going to pull out. So 3 times what gives me 27? 9. And then I have b squared. 3 times what gives me 21? Or what is 21 divided by 3? Same difference, right? So 7. And then I have 27, so that's going to be 9 again. 7, 9, or 9, 7, 9. So we're good number-wise. Going down the line, I have b squared. I have b. I have no b's. That means there's nothing else I can pull out. You're going to multiply down the side. So 6 is our GCF. 9b squared plus 7b minus 9. We factored by GCF. Now, after today, you would not stop here. You would factor again because I have a trinomial, right? The 9b squared plus 7b minus 9. Or we would at least try to factor again. But for right now, this is our GCF, and that's all we needed right at the moment. All right, so if we're looking at our next guy over here, -6, +9, 7. Do we have a number in common other than 1 between -6, 9, and 7? Right, perfect. There is not a number that is common other than 1 between -6, 9, and 7. There is a negative in the front, so I would say let's go ahead and pull out a negative, which we can call it a -1, because that's going to make your front number positive. The front number positive and to be a 1 is your goal always. Sorry. So after numbers, the next thing we're going to go to is our variable. We have a k in the first one, second one, and third one, so we know we're going to pull out a k. What's the lowest exponent between the three? Oh, be careful. Yep, there is no exponent, so there's actually a 1 there. So the lowest exponent is going to be that 1. So we're just going to pull out that -1k. So -1k means this 6 is going to turn into a +6 because -1 times 6 gives me the -6. I have 3 k's and I pulled 1 out, so how many k's do I have left? 2. Good. That -1's pulled out. So to make that 9 a positive, and I just wrote that plus getting all excited, we're going to have a -9 in the middle because -1 times -9 gives me +9. I have 2 k's. I pulled 1 out, so how many do I have left? 1. Perfect. Then we have, I about did it again, that +7, because we pulled out the -1, it's going to be a -7. I have 1k here and 1k out there, so we're done. So -k, 6k squared, minus 9k, minus 7 is going to be factored by as much GCF as neatened up as possible. So again, you factored by GCF here. And again, later we would want to be able to check and make sure that this trinomial can't be factored further. We're not going to do that right this second. Moving right along. So these are going to be a review. Hopefully not too hard. So I'm probably only going to do one of them because I want to get into the harder ones or what I've found students to find to be hard. All right, number 7. What is A? What is the numerical value of A? One. Good. What is B? Good. What is C? 14. Excellent. So A times C goes on the top, B goes in the bottom. Bottom starts with a B. So what is A times C equal to? 14. Good. Because 1 times 14 is 14. What is our B value again? 9, and it is a positive 9 because I'll ask you that in a minute. So now we're going to make our ACB chart, which is where we have 14, and we're finding the multiples of 14 that will add or subtract to give me 9. So we have 1 and 14, 2 and 7, 3 is no good, 4 is no good, 5 is no good, 6 is no good, we're back to 7. Which pair could I add or subtract to get 9? 7, 2. Good. 7, 2. B is positive, so our largest number has to be positive, and I need that 7 to turn into a positive 9. So we're going to do what with the 2? Add it or subtract it? Add. Good. So that's going to be positive. So it's going to be x plus 7, x plus 2. Said it a lot. Going to keep saying it. These are the factors. So if all it said was to factor, you're done. If they said to solve, what would we do next? I know you're tired of answering it, but do it again. Come on. Make them equal to 0 and solve, right? Set equal to 0 and solve for x. We're going to skip that for time. Do we need another one of these, or can we go ahead and jump into the next level? Okay, cool. I like it. Okay, brace yourself, my fun friends. So when A is not 1, I will tell you most likely, this is going to be a calculator active question, so you have other options as well. But we're going to learn the not as much fun one. First thing you always want to check for is GCF. Always, always, always. Because the smaller we can make these numbers, the easier our life will be. But in this case, 21 and 31 are not divisible by 2. They're not divisible by 4, so there is no GCF. So we're jumping head first in the deep end, all right? We're going to use our star like we had before, where it's AC's on the top. B's on the bottom, but we're going to add a new line. And A times X is going to go in the corner, and A times X is going to go in the corner. I know it's A for this problem, so it could be A times A, whatever, but that seems confusing. So we're going to pretend like all our variables on the sheet are X right now. So then looking at our problem, what is the value of A for number 9? 4. Perfect. What is the value of B? Negative 31. Excellent. What is the value of C? Good, good, good. All right. What is A times C? A times C. So A times C, so that'd be 4 times 21. It's going to give us 84. Our B value you said was 31, and it is negative, which we'll discuss that later. A value we said was 4, so we're going to put a 4x here and a 4x here. Now, we're going to find the multiples of 84, the add or subtract to give us a 31, and it's a negative 31. We'll discuss that in a little bit too. Remember, if you go to y equals and you type in 84 divided by x and hit second graph, you'll get all of your factors. So for 84, we got 1 and 84, 2 and 42, 3 and 28, 4 and 21, which we know that one. We saw that one. That's how we got there. 6 and 14, 7 and 12. And when your list starts getting this long, again, in your brain, just in case right now you're going, oh my gosh, that's so many. Very, very likely to be a calculator active question. And then 12 and 7 repeats itself. 1 and 84 is going to give me 85 or 83. 2 and 42 would give me 44 or 40. 28 and 3 are going to either give me 31. Ooh. So that's a good one, but let's make sure because this list is kind of long. 25 or 17, no good. 20 or 8, and then 7, 8, 19, so that's not going to work either. So it's going to be 3 and 28. Now, B is negative, so 28 has to be negative. To get to a negative 31 from that negative 28, what am I going to do with that 3? Add it or subtract it? Subtract it. Now, here's the only thing other than adding that 4x. And now hear me out because I've heard math teachers get really aggravated with me. The really mathy math teachers. But it works, so, you know, they'll get over it. So we're going to look at this side. So left side first. This is not a fraction. Hear me out. This is not a fraction. We are cheating the system, and we are going to pretend like it is a fraction. So if I'm looking at 4 over negative 28, is there anything, can I reduce that fraction, 4 and 28? And if so, what can I reduce it by? What number will go into 4 and 28? 2 is good, but I think we can do better. Because this is a star. That's why it's not a fraction. We're pretending like it's a fraction, but it's not a fraction. This is a big star. We're just now going to close in on this side, okay? And I say that because one math teacher is like, this is not mathematically sound. This is not a real thing. And they're not wrong, but if we pretend, we get pretty far, and it helps us a lot. Lots of students. So I'm going to divide it by 4, so that's going to become 1. Negative 28 divided by 4 becomes what? What goes into 28 4 times? So that's getting negative 7. So now I have a 1x over negative 7 and my not fraction. It's going to fall down 1x minus 7. Like, think about the building falling over. It's not a building either. So it just falls out. X minus 7. We're going to look at the second side, so the right-hand side. Again, not fraction. We're going to pretend. Can 4 over 3 be reduced? Or 4 over negative 3 be reduced? No. So it's just going to fall over like the Leaning Tower of Pisa again. So fall over, and that's going to be 4x, and that was a -3. So top of the fraction goes in the front, bottom of the not fraction goes in the back of each side. So each side is a separate set of parentheses. Now we have factored, and you're done. To solve, we would set them both equal to 0 and solve it. Because there's a 4x there, don't forget you have to get x by itself. This one is the kind we like, because that would actually probably be written as x minus 7, 4x minus 3. And then solve. Again, I'm going to skip that because we're running low on time. We got 15 minutes left, and I want to get through another one or two. We'll come back if we have time. All right, look at number 10. 7, 26, and -8. Do they have a number in common? Can I factor out a GCF? Can I factor out a GCF between 7, 26, and 8? No. Good. So we did our regular star like we've been using. So AC at the top, B in the bottom, AX in the corners. What is A in number 10? A is 7. Perfect. What is B? 26. Lovely. And then what is C? -8. Excellent. Proof of life. I got a couple of you being real active, and I got a couple of you being real quiet. We're not doing math yet, so there's no reason you can't type in unless you're doing something totally different. And at that rate, you're not attending class. Okay. So at this point, we're going to do A times C, which A we said was 7 times a -8. What's 7 times a -8? Good, good, good. -56, beautiful. Our B value is a +26. And the only reason we're discussing that's positive is because we're going to know in our factors which one needs to be, the big one has to be positive because B is positive. We're going to do A times X in the corner, or the upper part of our not fraction. We need the factors of 56, so the numbers we multiply together to get 56, that will add or subtract to give me 26. So we can do 1 and 56, 2, and what's 56 divided by 2? Good, 28. Lovely, lovely. 2 and 28. 3 is not a good one. 4 and 14. I'm cheating. I'm using my calculator now. And then 7 and 8, which is the one, that's how we got there. Which one of those pairs can I put together to get 26? Two and 28, right? Because this is going to be 57 or 55. This will be 10 or 18. This is going to be 15 or 1. So it's got to be this guy. So we're going to put the big one. I always put it to the left. It's my habit. 28, 2. B is positive, so 28 is going to be positive. So if I'm sitting at a positive 28 and I need to get to a positive 26, what am I going to do with that 2? Subtract 2. Good. So that's going to be a minus. Now, it's going to aggravate you how much I say it, but I say it again so that way when someone ever asks you and goes, that's not right, be like, no, no, it's not a fraction. We're pretending. So our not fraction. 7 over 28. Can it be reduced? Yes. What number? We got 7 and 1, so I'm not even going to go there. So that's going to be, we're going to divide that by 7, and I've just tried to draw 7 again, so that's going to become a 1. What's 28 divided by 7? 4. So we have 1x over 4. That's a positive 4. So we have our first factor. Our first not fraction gave us our first fraction. Not fraction gave us our first factor. So 7 over -2. Can 7 and 2 be reduced? Nope. Perfect. So then that rate, we're just going to boogie on down, top of the not fraction in the front, bottom in the back. We've now factored. These are our factors. Okay. All right. Number 11. We're going to draw our big star. We've added a line across. It's A times C on the top, B on the bottom, our A value with an X beside it in our upper corners, and then our factors are down at the bottom. So what is our A? I'm sorry, let's back up. Is there a GCF? 3, 16, and 21. Is there a GCF between 3, 16, and 21? No, right? 3 and 21 would be great, but 16 messes up the flow. So what is A? What is B? Good. And what is C? 21. Excellent. All right, so I saw a question mark. So remember, this is AX squared plus BX plus C. So that's where A, B, C come from. Now, you can also memorize it as left to right if it is in standard form. So highest exponent first, and then in descending order, as long as it's in standard form. So A times C is going to be 3 times 21. What's 3 times 21? $63. Our B value is 16. It is positive. A is 3, so we're going to put 3x and 3x. Now we're looking for the factors of 63 that will add or subtract to give me 16. All right, I'm not putting these in. You find it, however you want to find it. Factors of 63 that will add or subtract to give me 16. $21 and 3 is one of them. So we'll do 1 and 63. There's not a 2, 3 and 21. If I added 21 and 3 together, that'll give me 24. If I subtract them, that'll give me 18. So we're getting close. Yep. And then we have 7 and 9. And then the next one's going to be 9 and 7. So we've got our list. This is going to be 64 if I add it, 62 if I subtract it, 24 if I add it, 18 if I subtract it. So this is no good, no good. Add it 16, subtract it would be 2. 2 is no good, 16 is good. So we're going to go with 9 and 7. B is positive, so we know our 9 has to be positive. If I have a positive 9 and I'm trying to get to a positive 16, what am I going to do to that 7? If I have 9, if I take 7 away, that means I'm going to have 2. So if I add it, that's how I get to that 16, because we want 16, right? All right, not fraction. 3x over 9. Does it reduce? Yep. What is it? What are they both divisible by? By 3. Good. So we go 1, 3. 1 and 3 are beautiful. We know we've done everything. Top of the not fraction goes in the front, which is 1x. And then we have a positive 3, so that's going to be plus 3. Not fraction on the right-hand side. 3 and 7. Can I reduce 3 and 7 at all? Nope. Top of the fraction in the front, 3x, plus 7 in the back. And we've now factored it. Are we seeing the pattern yet? Good, 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 good. All right. Do we want to do one more, or do we want to try to squeeze in one word problem? Okay, word problems, because I know they're everyone's favorite, right? All right. If the side of a square, So if I were you, as soon as you read that, the side of a square, let's draw a square. What do we know about squares? They got 4 sides. What about their 4 sides doing that? Same sides. Good, good, good. All 4 sides are getting the same. So we know that this is equal to this, is equal to this, is equal to this. The side of a square is increased by 5. So we call the side of a square. And what does increased mean? What operation does that mean? Add. So we're going to add 5 to that side. And the area is multiplied by 4. How do you find area of a square? I'm hoping I'm not going to give you a bad one. What's the area of a square? Or area of a rectangle? We've talked about rectangles too. Same difference. Length times width, right? But in this case, we know that the length times width is the same thing. So side and side. So we're going to do x plus 5 times x plus 5. Is going to give us our area. And let me check something real quick to make sure I didn't give a bunk question because I did work it out already. Yep. And then the area is side times side, right? Side times side. So that's x times x. So area is x squared. We added 5 to it because that's what we changed. But x squared, so we're going to do 4x squared because that's the area, times x plus 5 times x plus 5. When we see x plus 5 times x plus 5, what's the first thing you think we should do next? Then we would be solving for x, but the problem is it's not set equal to 0 yet. That 4x squared messes us up there. Okay, so as soon as we see these, because we're not in a form where we're equal to 0. You want to multiply these back together and clean this guy up before we start to factor. So we're going to do x plus 5 times x plus 5, and whether you do FOIL or box method, because we have to clean up that 4x squared. So that's going to give me x times x is x squared, 5x, 5x, 5 times 5 is 25. So I now have 4x squared equals x squared plus 10x plus 25. Is everybody okay where those numbers come from? Now we want to get it into standard form, so we want to get it equal to 0. If I move the 4x squared this way, I end up with a negative x squared. And like I've said before, we want the front number in standard form to be positive, and if we're really lucky, we want it to be a 1. So we're going to move everything towards the 4x squared. How would I move that positive x squared over? Subtract, right? So that's 1. If I subtract 1 from 4x squared, I end up with 3x squared. I'm going to move this 10x over that side as well, and it's going to become what? We're going to subtract it, right? So it's going to be negative 10x. And we're going to move the 25 as well. So it's going to come in negative 25. And we couldn't combine that 10x with there because they're different terms. This is an x squared, this is a regular x, this is a 25. Now the whole thing is equal to 0. Now I know in your mind you're going to try to move that 4x the other direction because it makes sense to try to do so because there's less movement. But again, you end up with then you would end up with a negative x squared, and that makes factoring a lot more complicated. And we want to minimize complications. So we're going to factor this bad boy real quick, and then I'll let you go. A times C, 3 times a negative 25 is going to give me a negative 75. Negative 10 at the bottom. We have 3x and 3x. 75, the factors of 75 that will add or subtract to give me 10. It's going to be 15 and 5. B is negative, so the biggest one has to be negative. Negative 15. To get from negative 15 to positive 5, how did I get there? Add or subtract? We added 5 to negative 15 to get negative 10, so we're good there. Looking at our not fraction right here, can it be reduced? Yep. By what number? Close. 3. There it is. I see it. 3. So you divide by 3, that's going to give me 1. Divide by 3, I get a negative 5. 5 won't work because 5 doesn't go into 3. So that's going to be x minus 5. 3 over 5 cannot be reduced. So it's going to be 3x plus 5. And then we need to solve it. So x minus 5 equals 0. I'm going to move that negative 5 over. So I'm going to get x is equal to what number? Positive 5. So that's the first one in our list. And then I'm going to set this one equal to 0. I'm going to move the negative 5. So 3x equals a negative 5. I'm sorry, I moved the positive and turned it negative. How do I get x by itself on this guy? Am I done? Good. Divide by 3. Divide by 3. So negative 5 over 3 is our other solution. Algebraically, we have two answers. If you were to graph it in Desmos, you would see that parabola touch the x-axis 2 times at these 2 places. But because we are looking for the side of the square, are they both good answers? Ooh. How's a negative 5 over 3 as far as measurement? Can I measure a side of a square to be a negative number? Nope. So he's not correct for this question. So the answer would be the side of the square is 5. All right, guys.